Hey, welcome back. I'm John. This is the fourth video in our SPSS for Beginners video tutorial series. In the previous videos, we discussed the use of descriptive stats and we created graphs for our data. And today we're going to move forward and learn about correlation, specifically the Pearson product moment correlation. Determined by the Pearson product moment correlation coefficient, or Pearson's R. Pearson's correlation is used to measure the strength and direction of a relationship between two continuous variables. And so we'll focus today on our data and the relationship between height and weight. Now, a quick review, the range of Pearson's R is negative to +1. +1 value means a perfect positive linear relationship, where a -1 would mean a perfect negative linear relationship or an inverse relationship. And a value of 0 would indicate no linear relationship. For example, if you found a positive relationship between height and weight, it would mean that as height increases, weight also tends to increase. And so in our data set, each participant has a height and a weight recorded, except for the last two. It's important that you ensure that all of these values stay paired together. In our case, we have 10 pairs of scores, meaning our sample size is 10. If any data is missing, SPSS will automatically exclude those cases from the analysis. So let's calculate the correlation between height and weight in SPSS. And we'll follow these steps. We'll go to Analyze, and then to Correlate, and then to Bivariate. Now, by default, all of your variables would appear on the left-hand side. And so in the bivariate correlation window, I'm going to select height and weight on the list from the left and then move it to the right-hand box. Again, I can do that by clicking the arrow or dragging and dropping. And notice that the OK button doesn't light up until I drop both variables. So Pearson's R is the default method, but you'll see that SPSS offers other correlation methods like Kendall's tau or Spearman's rho correlation coefficients, but those are used for non-parametric data. And so we'll stick with Pearson's R since our data is continuous and fairly normally distributed, I would say. You'll also note that Pearson or SPSS assumes a two-tailed test of significance and that it wants to flag significant correlations automatically. And yes, we would like it to do that for us. So we'll keep the default settings there. All right, and once we have moved both variables, you can click OK and run the analysis. Now take a look at the correlation matrix in the output. The matrix shows the correlation coefficients for each pair of variables along with their significance levels and sample size. In the first row, the correlation between height and height is 1, which is expected because the variable always correlates perfectly with itself. More interestingly, though, you'll see the correlation between height and weight is 0.574. This indicates a moderate positive correlation. As height increases, weight tends to increase as well. Now, let's look at the significance level or p-value for height-weight correlations. Significance level and the p-value. The p-value is 0.083. which is greater than 0.05, which means that the correlation is not statistically significant at the typical 5% level. In other words, while there is a positive relationship between height and weight, you or one could not be fully confident that the relationship is not due to chance. Finally, notice that the sample size is 10 for both variables, which means SPSS included all 10 participants who had a complete set of data or both height and weight values in the analysis. Let's take it a step further by adding a categorical variable, gender, into the mix. We'll explore how gender correlates with height and weight. Go back to analyze, to correlate, to bivariate. And then we'll add gender to the list of variables. Excuse me. So the updated matrix now includes 3 variables: height, weight, and gender. Let's interpret the results. The correlation between height and weight is still 0.574. That hasn't changed. And still with a p-value of 0.83. 0.083, excuse me. Meaning that it's not statistically significant. The correlation between height and gender is negative 0.616, which suggests a moderate negative relationship. And since we coded males as 1 and females as 2, this indicates that males tend to be taller than females. The correlation between weight and gender is negative 0.770, which indicates a stronger negative relationship. This suggests that males tend to weigh more than females. Importantly, the correlation is statistically significant because the p-value is 0.009, which is less than 0.01, which is also what the asterisks mean. 2 asterisks indicate a correlation is significant at the 0.01 level with a two-tailed test. And 1 asterisk would indicate significance at the 0.05 level. So to visualize the relationship a little bit better, we can use a scatter plot. So let's go to graphs and then the chart builder. And down here, I'm going to choose scatter dot. And then I'm going to select the simple scatter. So not any of those, simple scatter. And I'm going to drag it up to the canvas. And I've already kind of done this, so it's already appearing in there. Next, I'm going to drag weight from the variables box into the y-axis. And then I'm going to drag height in inches to the x-axis. Okay, that looks better. And once I have them placed, I'll click OK. And now you'll see a scatter plot displaying all 10 pairs of scores. Each point represents one participant's height and weight. And you'll likely notice that as height increases, weight also tends to increase, which aligns with the positive correlation we calculated earlier. However, remember that this relationship was not statistically significant. And if I double click on the graph, I can add a couple of options to it, again, to kind of better interpret the data. And so to kind of more easily see the direction of the relationship, I can go over and add a fit line. Now, that line of fit is, if it were completely horizontal, it would be, zero, no relationship. And so, r squared of 0.3, so indicating, a very weak relationship, but a relationship. And also matching our correlation coefficient, which was related, but not statistically significant. And so that's how you perform and interpret a Pearson's correlation in SPSS. We explored the relationship between height and weight, added gender as a categorical variable, and learned how to interpret both the correlation coefficients and their statistical significance. Hang out with us for our next video, and we'll explore some more statistical testing through SPSS.